The question that I have is, how do you measure the permeability of soil? So the question has to do with measurement of permeability. There are two laboratory methods that are currently popular: constant head test and then variable head test. There are several field methods that are in practice currently, but we'll just talk about a test called pumping test because of its popularity, because of its simplicity, and also because of its relationship to fundamentals of seepage analysis. Constant head test is the simplest of all. So basically what you do is you take a soil sample and induce flow through it by applying a hydraulic gradient across its length. Typically, a setup like this is used, which allows you to maintain a constant water level over here and constant water level over here. So we take 2 points 1 and 2, one at the top, 2 at the bottom. Taking this as the datum, the total head at point 1 equals elevation head plus the pressure head, right? So that'll be y1 plus y2 plus y3. Now at point 2, the elevation head is this much, but the pressure head is negative because this is where the pressure is atmospheric, negative y3. So y3 minus y3 equals 0. And the difference in heads between the 2 points then works out to be y1 plus y2 plus y3. Now you can define a hydraulic gradient between points 1 and 2, which is delta h over y2. Darcy's law says the velocity equals k times I. And then you can calculate your quantity of water flow rate by simply multiplying the velocity by the cross-sectional area. And this leads to a simple equation for the permeability. So basically what you need to do is to measure experimentally the volume rate of water flow. So you take a little container and collect the water over a period of time, and then divide the volume of water that you collected by the time that it took for you to collect that much water. So you get the volume rate. That's all you need to do. Of course, you need to make sure that the flow is steady. So you would wait until number 1, the soil becomes fully saturated. Number 2, the flow becomes steady. For further details, I'll refer you to the book. Now on variable head test, which is also sometimes called falling head test, what you see in the picture here is a typical setup that is used in the laboratory. As the name implies, the head difference between points 1 and 2 is not a constant in this test. It is changing, it is variable. Taking this level as the datum, the head at point 1 is given by this equation right here, L plus Y3, where L is the length of the sample and Y3 is this distance right here that represents the pressure head at point 1. And the total head at point 2 is given by this equation. You subtract one from the other. We get this little h, which is this distance, as the head difference between points 1 and 2. Now we express the volume rate of flow in two different ways. First, like we did before, we use the Darcy's law, velocity multiplied by the cross-sectional area of the sample, and that gives you this equation for the volume rate of flow. We also can express the volume rate of flow from the velocity with which the water column is falling. And according to calculus, the velocity is dh over dt, and you multiply that by the cross-sectional area of the tube, and we have an equation for Q in a different way. But both represent the same thing, and therefore Q1 must be equal to Q2, and you substitute these expressions in that equation, keep simplifying it, and at some point you're going to get a differential equation that looks like this. And you integrate this between 2 points, point 1 over here and point 2 over here, and the time that it takes for the water column to fall from point 1 to point 2 is t. And the integration of the differential equation leads to this equation for t. You rearrange this equation. Now you have a expression for the permeability of the soil in terms of the geometrical quantities like the area of the pipe, the length of the sample, cross-sectional area of the soil sample, time that it takes for the water column to fall from H1 to H2. So during the falling head test, you measure the time that it takes for the water column in this vertical tube to fall from a height of H1 to H2, and then you can use this equation to calculate a value for the permeability of the soil in the tube. Now let's talk about field pumping test. The equations vary depending on the exact nature of the layer configurations in the field, but here I'm going to assume that we have a homogeneous soil and there is an impermeable layer at the bottom. So what you do is you drill a borehole and keep pumping water from this well. And let's say the rate at which you are pumping the water is Q. At some stage, conditions are going to reach steady. At that stage, the location of the water table will stabilize. Now, if I take a cylindrical region at a radius r, which is shown by this blue line over here, the water is kind of flowing into the cylindrical region, actually at different angles. But we are going to assume that the angle can be neglected and the flow is basically horizontal into this cylindrical region. So if I can figure out the velocity at which the water flows into the cylindrical region, then all I have to do is to multiply that by the area, surface area of the cylinder in order to get the rate of flow into the cylinder. And that's the quantity that comes out as you keep pumping. So we do make a number of approximations here. So to start the analysis, let me take point A and define the total head at that point. Taking this as the datum, then this is the elevation head, and the pressure head at that point is 0 because this is now exposed to the atmosphere. And therefore the hydraulic gradient for a horizontal flow is going to be dH over dr. In other words, a gradient of the head in the radial direction, right? And then by Darcy's law, the velocity is given by this equation, and the volume rate of flow is given by this equation. So here I am multiplying the velocity, which is this, by the surface area of the cylinder, which is 2 pi r multiplied by h. And now by rearranging this equation and integrating this between 2 points, point 1 and point 2, we get this expression for the permeability. So to implement this, we need to drill 2 other boreholes at radius r1 and r2 respectively and measure the height of water table in those boreholes. So in terms of details, this is a fairly simple test, but one thing to note here is that you are not really measuring the permeability at a point, you are measuring the permeability of the whole soil deposit in an average manner. So I have made a note here for you to read.